Good morning, everyone, and thank you for joining us this morning for the Webasto webcast. Paul Bacheski, the National Account Sales Manager on the bus side for Webasto, has joined us this morning to present the sales and technical side of the Webasto product. We appreciate him joining us and appreciate you all joining us this morning. And with that said, Paul's going to take over the seat and begin with the presentation.
Good morning, everybody. Don't all respond at once there. As Gina said, my name is Paul Bacheski. I'm the National Account Manager as far as Webasto is concerned for the school bus market. To my knowledge, you guys will have access to this presentation in the future. So I've included both my email and my telephone number there to where if you guys have any questions or concerns further down the road, feel free to contact me by all means. There she goes. I put together a fast agenda for y'all. Want to look real briefly into the operation as far as what the Webasto is actually supposed to do, along with what kind of benefits are going to be achieved from it. We'll take a look technically as far as what's happening on the inside and go through a lot of the service parts that are going to be involved inside that. And then we'll take a peek at the documentation as far as what's available to you and where to access it. And then from there we can open it up as far as questions and answer any kind of concerns that you have. So if we jump right in and we look as far as what the Webasto is actually supposed to do, the unit itself is integrated into the electrical system of the vehicle, into the coolant system, and into the fuel system. It can be activated either via an on-off switch or a timer, which a timer is the typical application that's out there. A school district, a driver, whoever it happens to be who's in charge of that timer, will typically set that unit to come on 1 hour prior to when that vehicle is going to be put into operation. When the timer comes on, activates the Webasto will start pulling fuel out of the tank. It'll burn that fuel. It'll transfer the heat that's being generated into the coolant system, and then with the Webasto circulation pump, it'll start pushing that hot water through all the heat exchangers, through the defroster, and back through the engine. Once you do that, we're not going to go through each individual benefit of it, but a whole bunch of good stuff starts happening, including having a real positive effect on a lot of the emission devices such as DPFs that are out there. And if anybody has any questions or wants to go into more detail of that, we can obviously do such at the end of the presentation here. If we look at how this thing actually operates, there's an electronic control unit that sits right on the front of the unit, and this electronic control unit is actually telling each individual function when to happen and how to happen. There's 3 wiring plugs that go into the bottom of this thing. All 3 plugs are of different sizes and of different shapes, so it's impossible to incorrectly wire that thing together or incorrectly hook it up. That control unit, as I mentioned, does all the operation to the heater. When you first turn this product on, that control unit will send a signal to there she is. We'll send a signal to a 12-volt motor, which is located underneath this black shroud. That motor will start turning, and basically what it's doing in there is it's driving an internal fuel pump, it's driving an internal combustion fan, and it's getting the product ready to operate. And we'll be taking this thing apart here visually to let you look at the inside, obviously. But that fan motor, as I mentioned, is driving both air and fuel, and it's prepping the unit to start operating. After about 20 seconds, you'll hear the unit light off. There's a flame which will be created through this yellow heat exchanger portion, and that's where the heat is actually being generated and being transferred into the coolant system. You have water or coolant which is coming into our water pump, goes through the heater, and comes out this top port. That process will continue until the water temperature in the heater hits approximately 175 degrees. On a cold-soaked conventional chassis, and if we have a bus which is cold-soaked to around 0 degrees outside Fahrenheit, that process between going from 0 to 175 should take approximately 30 to 35 minutes. Now once we hit 175 degrees, the flame is turned off, but that fan motor continues to run for approximately 2 minutes. And it's very important that that portion happens, and we'll go through why here in a minute. But that fan motor will continue to operate, and basically what it's doing is it's just pushing air through the middle of that heat exchanger, trying to cool itself down. Once the water temperature comes down to approximately 160 degrees, the process restarts itself again. So basically what we're doing is we're just monitoring temperatures between the 160 and the 175 F range. Heater comes on, generates heat, water temperature goes up to the 175 degrees. What happens next is under this black cap, and this black cap is located right up here on the top left-hand corner of the heat exchanger. Underneath that black cap are going to be 3 different devices. You have 2 thermostats and you have 1 fuse. The part here that has the red and the green wires going to it is a regulating thermostat. And it's just it's a bimetal thermostat that opens with temperature. When the heater is cold, when the coolant is cold, if you were to put an ohm meter across this, it would be a 0 ohm short circuit type of a product. Once this thing gets hot and hits the 175 degree range, the bimetal contacts with inside of this part open up, and that's what's telling the heater to turn itself off. Again, those bimetal thermostats or those bimetal contacts will reclose up at approximately 160 degrees. So we can control really whatever temperature we want this heater to run at simply by changing that part. If we wanted to run it cooler, we wanted to run it hotter, we can put different thermostats onto that product or onto that port. Sitting right next to this is a thermostat that looks almost just like it. It's just that it has 2 green wires coming to it. That is an overheat protection to where if for some reason my water temperature starts going higher than 175, when that water temperature gets up into the 215, 220 degree range, it's an overheat protection to where it works the same way. The bimetal thermostats open up and just says, hey, you're getting too hot underneath there, turn the unit off. If you do overheat the system, the only way for this thing to reset itself is to let the coolant temperature come back down under the 160 range, which at that point the bimetal thermostats will both close, and you have to turn it off at the dash and turn it back on again. So it has to be reset both by temperature as well as electrically through the control unit. You got 2 common reasons on why you would be overheating the Webasto. The first is going to be that if you've got a valve shut down in the system, driver goes on, turns the heater on, the Webasto will start operating, but it's only heating the water which is within inside of itself, and it will do that very, very rapidly. I mentioned before that at 0 degrees this thing will run for about 30 to 35 minutes. If you're finding that the thing is only running for 3 or 4 minutes at a time, you've got an issue where you have an issue where we're heating just the water within inside of it and it's not being moved. The unit will just start short cycling itself. Eventually what happens is you will create a small air pocket in there. You'll get the water temperature, which will spike up and will turn that thing off. The other reason is if you've got it plumbed backwards, once you start the engine coolant flow and the Webasto coolant flow are kind of fighting each other, and it takes out any flow through the unit, which can again overheat it. If the driver complaint is that the Webasto works fine in the morning, but when I start my bus I have no heat, what's happening is you don't have any kind of coolant flow because the two systems are both deadheading right up against each other. Again, it will create a situation where you can overheat the unit. The third product that's underneath this black cap is a double white wire which ends up onto what I'm going to refer to as a melt fuse. And this melt fuse is wired in series with that double green overheat thermostat. That fuse is put in there basically to detect air. If you've got air in the system, you're going to have a real quick, fast heat spike, which will blow that fuse out. That fuse is rated at about 280 degrees, so it does take a lot of heat to burn it. Again, if you've got air sitting inside of the system, it will go up to that kind of temperature and even higher very, very rapidly. That fuse sits down into what I'm going to refer to as a dry well. And when you put that fuse in, don't take it and tighten it down to a point that it's really, really snug. What can happen if you do that is this little waxy substance on the bottom of it will actually bottom out against the heat exchanger, and it will make it very, very sensitive. Get into a habit that when you put that thing in, you take it all the way to the bottom and then even back it off a full turn just to make sure that that little waxy substance is staying away from the top of the heat exchanger. That melt fuse is a part to where if I had a fleet locally to me that had 10 Webastos inside of it, I would make sure I had a good handful of those things on the shelf at the beginning of each season. It's a rather popular part that people go through, but that part is put in there obviously for a reason, and that's to help overall protect the heater in regards to being very, very hot. All three of those parts that are located on top have a black protection cap that sit over the top of it, and on that cap it will tell you what number plugs they actually plug into, and it will give you the part number for each individual part. You're going to probably see, I'm going to say 75% of all the problems that you have with this product sitting underneath that black cap. If we look at the inside of the unit, and to take the burner head off, you've got two 10mm eye bolts. One is labeled up on the top. The other one is kind of on the bottom front end portion of the unit. Sometimes it's a little difficult to find it, but you got two 10mm eye bolts. You'll also have a cotter pin which will sit right through these two ears on the unit. The first time you open up that burner head, remove that cotter pin, and you can go ahead and throw the thing in the garbage. You don't have to replace it back in there. Once you take the burner head off, you basically have 5 major components on the inside of this thing. Sitting on the bottom at about 6 o'clock is a fuel pump. Obviously its job is to make a vacuum and bring fuel up to the heater. That fuel is then passed along past a 12 volt fuel, I'm going to call it a fuel solenoid or a fuel plunger. There's just a electromechanical plunger that sits through the middle of this, When it has 12 volts applied to it, it's pulled back, allows fuel to come out of the fuel pump and up towards the nozzle area, and then virtually coming out of the nozzle. Over the top of that nozzle is a 12 volt coil. It's a 6,000 volt coil. If you guys mess around with it in the shop, it'll pick you up and throw you right across the room with no problem. But when I'm first turning that unit on, I said for 20 seconds that fan motor is spinning. Basically what it's doing is priming fuel to come to it. Fuel comes up, comes through that nozzle. We make a spark with our electrodes and we create a flame. Once that flame is created, there is a photocell that sits right next to the nozzle area. That photocell changes resistance with light, and it's the signal that that electronic control unit is looking for to say, hey, I lit. It sees the light of that flame and it turns off the coil. If for some reason it does not see any light, it will only let that magnetic solenoid stay open for about 20 more seconds before it shuts it back down. So it's the internal part that is monitoring the flame and saying, hey, either yes, I am working, or no, that I'm not working. This part looks like this when it's removed. It has a glass topping to it. It works under a vacuum to where if you see that this thing is cracked or maybe has a pit in it, any kind of marking on that at all, if it's working today, odds are it won't be working tomorrow. Once that product or once that piece loses its internal vacuum, it will stop working. If that part fails, the symptom of the heater is very easy. It's that the heater comes on, it runs for 20 seconds, and it turns right back off. And that's happening obviously because it can't see any light and the product is not working. The part that is put onto is this big round disc. And this disc should be flat, and it also should be very loose, or it should float. If you grab it with your hands, you should be able to kind of jiggle it around. And the reason for that is the air that we're using to burn is being brought in through the bottom of the unit. We'll look at that here in a second. But that air is coming out a hole which is at about 11 o'clock on that whole burner assembly. And then it is being shot into the heat exchanger on the outside portion here of this cup. That round disc that has the nozzle on it and has that photocell is making a seal on this cup on the inside. If that disc is bent at all, what will happen is that air that is generally going through this heat exchanger will actually turn around and come into that nozzle area, and you'll start putting a lot of carbon or a lot of black soot over the top of that photocell. And what the result is that the photocell, even though it's working and the photocell is good, it can't see through all of that heavy carbon, so it never changes resistance and never allows that heater to operate. So again, that disc is making a nice seal around this area with the nozzle going right through the middle. You can pull this heat exchanger out or this burner tube out, and I'm a big fan of if it's not broken, don't fix it. But any time that you do open up the burner head to the Webasto, get in a habit of pulling out this burner tube, and you may have to take a flat screwdriver and a mallet and kind of give it a whack in here to kind of separate the two. But you can pull it out, slide the thing right out, and what you're left looking at is an empty heat exchanger. take a wire brush to it. If you got any kind of carbon buildup on the inside of it, go ahead and get that stuff out of it. Throw a shop vac, whatever you have to do. This is what that combustion tube is going to look like when it's brand new, and this is going to be the inside view of it again when it's brand new. And you can kind of see the air holes where the air is coming through that's being used to burn, and it kind of does that inside of a circular type of a pattern. When you pull the thing out when it's been used, and again, anytime you do open up the burner head, I would kind of recommend doing this. When you pull this burner tube out, you can look at it and really get a good feel on what's going on with the product. You'll have about 2 inches of carbon up on the front hand portion, and then the bottom portion here should be nice and clean. This is the hot area, so anything that's on this portion is kind of burnt off. This is the cool area where you'll get a little bit of carbon being built up. If you're seeing carbon building on the back end of this thing, one of two things is happening. Either I have a nozzle in there which isn't atomizing properly, so I'm not getting a good spray pattern through the middle of it, or I have a voltage problem to where that fan motor isn't pushing that airflow fast enough or hard enough through it, and it's allowing that flame to more or less back up. If I look at the inside of that burner tube, I should see a nice circular round burning pattern on the inside. If you're noticing a lot of carbon chunks that are getting built up on one side of it, what's happening is that nozzle that's coming through the middle is just kind of squirting over inside of one direction. It's starting to become clogged and may be inside of need of being changed. These nozzles have two different markings on them. One is going to say 0.60, I'm sorry, one is going to say 60 degrees. That's the angle of the cone spray that comes out of it. And the other is going to say 0.35. That's how much fuel can come out of that orifice with 100 pounds of pressure behind it over 1 hour of time. Again, if you've got a fleet nearby that is running, let's say 10 Webastos in it, I would make sure that I have 10 of these nozzles on the shelf at the start of the season. You can disassemble these things when they get clogged and attempt to clean them. There's an internal filter, which is the first one shown, which will actually sit on the inside of this. And then you have an external filter which screws onto the back of them. You can attempt to clean them, putting them through a parts washer. I would recommend soaking them overnight in like a WD-40, something which has a little bit of lubricant to it to keep it moist before putting it together. In the long term, it's more of a Band-Aid than anything, and will require to be replaced over time. The longevity of these nozzles really go hand in hand with the quality of fuel that the fleet is operating. If they're buying good quality fuel, I've seen nozzles go 7 and 8 years out there. If not, there's fleets that will be replacing nozzles, 2 or 3 times a season. If you wanted to look to see what kind of a spray pattern you're actually getting out of the nozzle, you can go back to the coil. There's 4 screws up on the top that you can take off. Underneath it is a quick disconnect. You can disconnect the coil and start the heater up and watch to see what kind of a spray pattern comes out of it. If you're seeing a lot of, again, real heavy fuel droplets coming out inside of one direction, that thing is becoming clogged and needs to be changed. While we're talking about the coil here, attached to the end of the coil are 2 electrodes. Those electrodes over time will burn away. The length of that goes on how much usage the product is actually getting and how far into the spray pattern those things are set at as far as the gap of them. If you do have to replace them, These electrodes will pop out individually. You do not have to replace the entire coil. Anything on the product which is voltage sensitive, one obviously being the coil, the other being the electronic control unit, we label these things in red. You'll have a lot of red writing on it, or as you can see on the bottom of the coil, there's actually a red plate that's stamped right to it. Again, that designates a 12-volt system to us. If you're getting any product that has a lot of green on it, just the opposite. That's all 24-volt systems. So again, just keep in mind that if you are replacing a part which is voltage sensitive, it will have and should have some sort of a red indication to it. We start looking at the rest of the unit. There's 4 bolts that hold the whole internal structure together. You take those 4 bolts out, and as the picture shows, you can pull that whole piece out as one assembly. On the back of it, you'll be able to see the gear which is driving the internal fuel pump. That's the actual back of the fuel pump. The only reason why you'd ever have to get there to take it apart down to this level is to replace that fuel pump. Obviously there's a little spring clip right here on it that'd have to be taken off, and you could pull the shaft of the pump right out. Looking at it from the other view, you can see a small brass gear which is driving that pump, with the pump gear obviously sitting down inside of this bucket here. Very well protective. There's no reason to get in there to do any kind of lubrication or anything like that. You have the electronic control unit, which is again mounted right to the black shroud. On the bottom of it here is an air intake. These are all preset at our factory, and they are good to roughly about 5,500 feet altitude. If you are going higher than that, it may be necessary to open that up a little bit. There's a small set screw on it that would have to be loosened in order to open it. There'll also be a dot of paint on where it was set from our factory. Over time, sometimes it is necessary to where as there's wear and tear on the product, and basically as a fan gap in here starts to get a little bit longer, that you will have to go and readjust that, but very rare. You have 4 screws rotationally that go around this shroud that you can take off and expose the underneath of it, which is basically just a 12-volt motor. That 12-volt motor sits on a plate, and I should note that if for any reason you ever take it down any farther than this, please mark it, because it does have to go back together in the exact same fashion that it came off in. But that 12-volt motor has a very small shaft to it, which then goes into what I'm going to call a clutch half, which are just 2 nylon drive gears. If you do get something sucked up into the air intake, a large stick, let's say, if you get something put in there large enough and hard enough, it is possible to kind of strip out these little drive holes, and at that point you'll have a free-flowing 12-volt motor turning, obviously, a very high-pitched hum. Those clutch halves connect to this shaft right here. In this picture we've taken off this cover, and we're exposing a fan, which is what is actually making a suction to bring the air in that's being used to burn. On the other end of that shaft is this gear, which again is driving the fuel pump. So it's kind of easy to show that that 12-volt motor is both driving air and driving fuel. Keep in mind that in series with that 12-volt motor is an inertia switch. And that inertia switch is put in there to where if something catastrophic happens, bus rolls over, that switch pops, and it will discontinue airflow and discontinue fuel flow to the heater, ultimately turning the thing right off. If you turn the heater off instantly, Obviously everything shuts down. The bad part of it is you have a lot of heat which is built up inside of this heat exchanger. That heat will radiate very, very quickly and will generally burn out that melt fuse, that double white wire that's sitting underneath it. If you have fleets that are having issues with this inertia switch prematurely going off, maybe they're running routes where they're hitting speed bumps, a driver hits a curb at 30 miles an hour, whatever it happens to be, there is a process that we can relocate that into the timer circuit. And if you need more detail, get with me afterwards or give me a call after this thing is done. I can walk you through that process. And basically what happens is we end up relocating that up into the driver's area to where they can sit and push that button all day long. We make a diagnostic test tool to help you go through this thing to figure out what's going on. Basically, and there's a couple different versions of this box laying out there, but they all work the same. You'd end up taking the 3 electrical connections that are on the bottom of the electronic control unit, and they get plugged up to the diagnostic test tool. On the tool, you've got 3 lights, you've got 2 buttons, and you've got 2 switches. The very first light is just a battery indication, and it's saying, hey, I've got a good 12 volts coming to the unit. The light's not coming on, your problem is you don't have any power. You have 2 switches. One is labeled water pump, one is labeled motor, which is a 12 volt fan motor. When you turn those on, you're actually activating both of them. You'll have your water pump running and you'll hear your fan motor going. If your fan motor does not come on, 99 out of 100 times that inertia switch is popped and you need to reset that in order to get power to the motor. You have an ignition coil button to where when you push it and you hold it, you'll actually be able to hear that 12 volt coil in there snapping. Fuel solenoid button, same thing. You push it and you're giving 12 volts to that fuel solenoid. You're pulling back the plunger. You're allowing fuel to come through the system. In order for that fuel solenoid to work, both thermostats on top of the heater as well as the overheat fuse have to be closed. If the bus just came in from being on the road, water temperature is hot, it's above 175 degrees, thermostat is open, if I hook this box up to it, this fuel solenoid will not work until that water temperature drops back down. If all 3 pieces on top are closed, I turn the water pump on, I turn the fan motor on, I hold the fuel solenoid open, and I give it a spark with the coil, you'll actually light the heater off. At that point, the flame control light will come on, indicating that the internal photocell has changed resistance. If that light comes on kind of dim, it's changing resistance kind of dimly. It's starting to get a little bit of a carbon coating over the top of it. The reason why not fully changing resistance and the reason why not giving you a full red light to it. So you can check 99% of the entire product with this box within a couple of minutes without opening the thing up. If you hook up the box to it and everything works, but you go back and you hook it up to the ECU and it doesn't work, it doesn't necessarily mean that this ECU is bad. On the front of it is a label that shows you which each individual pin is responsible for. And I know it's a little bit difficult to see, but the main battery input is coming in onto what we refer to as B4. I already know that I have power at B4 because my idiot light over here came on when I hooked it up to the diagnostic test tool. The switch or the timer is ultimately coming through onto B1. If everything is closed on the top of the heater. The regulating thermostat, the overheat, and the overheat fuse are all closed, and I jump B4 to B1, the heater has to take off. It has to operate. If it doesn't, then this control unit is bad and needs to be replaced. If it does turn on, there's two more parts that we haven't looked at. One of them is a relay which sits on the back of the heater, and basically this relay is put in there to where whatever I'm using for an on-off type of a device is tagging this relay and sending the signal down to the heater. If that relay is stuck, obviously the heater's never being told to turn on, hence the reason why it's not operating. The other thing it can be is a bad timer, to where the timer is not outputting a signal to the relay, and the timer is bad and needs to be replaced. So again, if you go through the whole process with the diagnostic test tool and things don't work, you need to go back and check these last two parts. If we can get into the documentation, we've got a website set up called www.techwebasto.com, and this website, it's an American-based website, and it's something that we put out there to house technical documentation. I know it's a little bit difficult to see, but in the top left-hand corner of the website, it'll say Academy Documentation, Warranty, or Contact. If you go through the documentation portion of it, it'll keep expanding out, but if you check heater, you can check service parts, and it will show you a listing of all the different heating products that we have. The product we're talking about today is listed under what we call the DBW 2010 family of heaters, and underneath that it will show you a bunch of different manuals which are available. You can download the part listing. When you do that, it'll give you the entire manual, and within that we'll have a lot of explosions as far as part explosions, along with the corresponding part number. If you download a manual today and you order a part today, you should have the correct part number for that corresponding part. If I change a part number, my last process is to change it in the manual and to dump it onto this website prior to that thing being changed. So if you, again, download a manual today, you should have the latest and greatest and the most up-to-date part numbers that are out there. If you did it 2 years ago and you go to that, you can run into an instance where you're ordering a part which is no longer available. Something new that we have recently added to this website that I want to show you is what we refer to as a 3D product reference. And I'll use this a lot when somebody calls, has an issue, maybe not real up to date with how the product operates or what things look like on the inside. But when you go to that reference and you download it, it may take a minute or two for it to open for you. But basically you'll come out with a portal that looks like this. Shows you the product, gives you a listing of all the different parts that are on the inside as well as on the outside of the unit. You can pick whatever you want. For this application, I just chose the fuel pump. If you were to click on that, it would bring you out a picture of just the fuel pump. You would be able to grab that fuel pump with your mouse. You'd be able to rotate it. You'd be able to look at it from all different angles. So it kind of gives you a little bit of a confidence that if I'm talking about a fuel pump, that the part that you got in your hand is actually what we're trying to refer to. So with that, I guess I'll just open it up to see if there's any kind of questions, any kind of concerns. Anybody wants to donate to the Buy Paul a Porsche Fund? Alrighty, I guess we'll call it that. And again, on the first slide, I had my contact information as far as my email address as well as my telephone number. feel free if there's anything that I can do for you as far as from my end. So, thank you guys for all attending.
Thank you guys for attending today, and Paul, thank you for the presentation. If there's any follow-up questions, please feel free to email Paul your RPMs or send those questions directed towards me, and we will definitely be happy to get back to you as quickly as possible. Everyone have a great day.
Thanks, Gina.
Thanks.